Yeah, wonderful. Thank you for the introduction, and good morning or afternoon, everyone. I think it's past 12 o'clock now. It's an absolute pleasure to be here. And firstly, let me extend my thank yous and invitation to speak today. I truly appreciate the opportunity. So I hope by the end of this presentation, you leave with a little more insight than when you arrived. If that happens, I'll consider this a success. So my job today, at least, in the next 25 minutes that I've been given, is to walk you through the deep interconnection between the global food system and the Earth system. I will try to offer you a storyline and a perspective that operates at the planetary scale. And then my colleague Juan will follow with a much closer look at how these dynamics play at the national level. So since the mid-18th century, the world has experienced an extraordinary surge in social economic growth, what scientists refer to as the Great Acceleration. This rapid expansion has exposed how deeply connected that our social, political, economic, and technological systems are with the Earth's biophysical systems. So to put simply, we're no longer just inhabiting the planet, but we're reshaping it. Humanity has altered the biosphere on a scale that now rivals geological forces. So we've potentially pushed the Earth beyond its natural glacial, interglacial rhythms and onto a trajectory towards a much new, hotter, and far less stable climate state. That brings us to a really critical moment in history. So the decisions we make, not just in the next century, but in the next 5 years, will shape the behavior of the Earth system for the next centuries and even millennia to come. So to understand where we are in our ecological journey in the 21st century, let's take a step back, about 12,000 years, to when the last glacial period ended and Earth entered this remarkably stable climate phase known as the Holocene epoch. So this epoch brought with it a kind of steady, predictable climate conditions that allowed human civilization to flourish. It was during the Holocene that agriculture emerged, providing this consistent food supply and laying the foundations for societies, cities, and complex cultures. And it's Earth's own self-regulating systems that have helped maintain this balance, which supports a world of flowing rivers, the stable ice caps, rich forests, and this abundance of biodiversity. So this mild and moderately wet world that we know is the one that we all collectively depend on. And in the absence of human interference, scientists estimate that this climate stability could have lasted another 50,000 years. But instead, as we all know, decades of unchecked, human-driven environmental degradation have begun to really undermine the resilience of these planetary systems. So bit by bit, we are destabilizing the very conditions that have made life as we know it possible. So we are moving away from the safety of the Holocene towards what scientists now warn could be a hothouse Earth, a fundamentally different state of the Earth system that is characterized by rising temperatures, altered rainfall patterns, and irreversible feedback loops. And so the systems that have kept the planet within this Holocene-like state, which is the state that has allowed life to thrive, has been successfully quantified by what's known as the planetary boundaries. So this was a framework that was first introduced in 2009 by Johan Rockström, and leading Earth system scientists. And only in September 2023 did it receive its most comprehensive update yet, making it the first time that all 9 boundary processes that define this safe and operating space for humanity have been fully assessed. So these planetary boundaries, they define the safe environmental limits within which humanity can operate while maintaining the stability, the resilience, and then the life support functions of the Earth system. So when we cross these boundaries, we are increasing the risk of triggering irreversible tipping points. These are points beyond which the Earth system could shift into a fundamentally different state. So where are we now? Well, we've already exceeded 6 of the 9 planetary boundaries, and we're dangerously close to breaching the 7th. So let's take a closer look at what's driving these transgressions. As expected, maybe, the burning of fossil fuels is a major contributor, especially to climate change, as you can see here. But here's the important point I want to make. Climate change is only just one of the 9 planetary boundary processes. The other boundary transgressions, they're being driven primarily by our global food system. These two, so our dependence on fossil fuels and our industrial animal-based agriculture, are often referred to as the 2 pillars of planetary overshoot. So together they place this immense pressure on the Earth's life support systems, pushing us closer to abrupt and potentially irreversible environmental change. So let's take a look at this in a slightly different other format. So what you're seeing here is a visual summary of the 9 boundary processes. So each bar here represents a boundary from the safe zone in green, through zones of increasing risk, to a high-risk state in deep red and purple. And the white circles, they show where we currently stand. And as you can see, we've already crossed into dangerous territory on most of them. So now look to the right side of the slide. Here's your fossil fuels, and here is your global food system. So that little icon, that little cow icon, is not just a cute graphic, right? It is a warning, and it shows where agriculture, especially animal agriculture, is the primary driver behind these boundary transgressions. So let me just highlight a few just to give you a taste. So for greenhouse gas emissions, we see that food systems contribute around 1/3 of global emissions, making them the single largest emitting sector. Within land system change, we see over half of all Earth's ice-free land has been converted, primarily due to agricultural expansion, where over 80% is used for farming animals. In biogeochemical flows, we see fertilizer runoff is pushing us far beyond the safe limits of both the phosphorus and the nitrogen cycles. In freshwater use, we see that agriculture actually accounts for 99% of global freshwater footprints. And finally, within biosphere integrity, we see that we're losing species at a rate that threaten the functional integrity of ecosystems. And again, agriculture, especially through deforestation for pasture and feed crops, is the main cause here. So while climate change often dominates the conversation, it is clear that our global food system, as it currently operates, is driving multiple systems out of balance. Now, I won't go into detail in each one right now, but I will take you into more detail in just one of them, land system change, which is one of the most critical drivers of Earth system change, given its coupling with the other processes as well. So now I want to stay on this topic a little bit longer, because land system change, particularly through deforestation, is not just a major boundary transgression on its own, but it also has deep interconnected impacts on climate, biodiversity, and ecosystem functioning and resilience. So I want to take a moment to really break down how land is used on Earth. So the Earth's surface is about 29% land and 71% ocean. Of that land, around 90% of it is ice-free. And of that ice-free land, about 54% has been converted into agricultural land. And then what's left of that? Well, roughly 45% remains as natural and semi-natural ecosystems, and just 1.5% is taken up by urban and built-up areas. Now, this is where it gets really interesting and particularly concerning. So today, 83% of that agricultural land is used to produce animal-based foods. But those foods, they provide only 18% of global calories and 37% of global protein. Now, in contrast, only 17% of that agricultural land is used for plant-based foods. Yet it delivers 82% of global calories and 63% of our global protein. So this is a massive efficiency gap, right? Animal agriculture is a highly inefficient in terms of land use. And now here is where the transformative potential is. So research shows that by shifting towards more plant-based diets, we could free up around 75% of that agricultural land that we use today. That is roughly 3.1 billion hectares. Just pause for a moment and reflect on what that means, right? 3/4 of current farmland can be repurposed, not just abandoned, but actively rewilded, restored, regenerated. We could rebuild ecosystems with that. We could reestablish biodiversity. We could design a food system that works with nature instead of against it. And this is super critical. Because when we appropriate land for industrial agriculture, we are destroying habitats. We are replacing rich, complex ecosystems with monocultures, pastures, grazed lands. We are pouring nitrogen and phosphorus in the form of fertilizers, which wash into our rivers and oceans, creating dead zones. These are anoxic areas where life cannot survive. And all of this is eroding the resilience of ecosystems. Systems that have taken centuries to evolve and that provide critical functions like carbon sequestration, water cycling, nutrient transport, and climate regulation. These are not luxuries. These are the essential life support systems of the Earth. These are pillars of biosphere integrity that we are all collectively dependent on. Now, some people may ask, rightly so, can we really feed the world within planetary boundaries? The answer is yes. Research shows that we can nourish the projected 10.2 billion people by 2050 and stay within planetary boundaries, but only if we transform both how we produce and how we consume food. To grasp the scale and the speed of land system change, it helps to see it with our own eyes. So here is a satellite image of Rondônia, Brazil, taken in 1989. Now here is the same region just 30 years later. So what you are seeing here is a visual record of deforestation. This is land cleared year by year, primarily for cattle grazing and soy production to feed animals. And so this region, which was once part of a vast Amazon rainforest, is now fragmented into a patchwork of pastures and agricultural plots. It is not just trees we are losing here, right? It's entire ecosystems. And with them, we are undermining then the biosphere's capacity to regulate the climate, cycle water, and support life. This is what animal agriculture looks like from space. And it's a reminder that our food system isn't just written into policy reports or scientific papers. It is written on the surface of the earth itself. So if you're still not convinced on the central role of our food system plays in the climate crisis, maybe this will do it. So to limit warming to 1.5 degrees, we need to cut global emissions by half every decade, reaching net zero by 2050. I mean, that alone is a massive challenge. But what makes this even harder is that all of these climate models, they've assumed a number of optimistic conditions. One of them is that the Earth system remains relatively stable. The second is that forests and oceans continue to absorb carbon. And third, most crucially here, is that agriculture, forestry, and other land use, also known as a FULU, shifts from a major source of emissions to a net sink in the next 25 years. So right now, what we see is that our global food system emits around 4 billion tons of CO2 annually. And by 2050, models have assumed that flips to absorbing 5 billion tons. That's a 9 billion ton turnaround. One of the most ambitious transformations that any sector is expected to achieve. And we're not on that path. we haven't even started. In fact, current trends show that food-related emissions are still rising. So unless we completely, radically rethink how we produce and consume food, then these safe transition pathways just won't hold. Now, if you look at the graph on the right here, this graph shows the greenhouse gas mitigation potential of different diets. And right there at the top, the single most impactful lifestyle change we can make is adopting a vegan or plant-based diet. That one shift creates the greatest potential to cut emissions on the demand side. So, through our current way of life, and especially our consumption of animal products, we're asking an already stressed Earth system to carry an even heavier load and somehow remain stable. But systems have limits. For most of human history, we have lived in this stable state, the Holocene, a period of really rare climate stability that have allowed civilizations to grow. But human pressures have pushed us into a state of uncertainty, which is undermining the resilience and threatening the destabilization of the Earth systems. This new era, the Anthropocene, is defined by this deep uncertainty. In my analogy here, the chair is already tipping. And if we continue on this path, we risk crossing Earth system tipping points. These are thresholds that trigger runaway feedbacks, like ice sheet collapse or forest dieback. And beyond that lies a new state, an unfamiliar, hotter, more volatile, and potentially hostile Earth system that humanity has never known. And the most critical threshold here is the 1.5 degrees. It is a physical limit of our planet. It is not a political target. And we're on track to cross that in 2029, according to the latest Copernicus reports. So the path we take depends on what we do right now. So where does this leave us? Yes, it leaves us with an immense responsibility, but it also leaves us with a colossal opportunity. Transforming our food system, especially moving towards more plant-based, regenerative, and equitable models, offers one of the most powerful levers that we have to stay within planetary boundaries. Just for a moment, imagine the benefits here. We are freeing up 3.1 billion hectares of land for restoration, for rewilding, to restore the resilience. We are reversing the emissions from a 4 billion ton source to a 5 billion ton sink. We are restoring ecosystem functions, halting biodiversity loss, restoring the biosphere's innate resilience that protects us from climate shocks. And all of that, we get to also improve human health with healthy diets. We get to reduce water stress, and we ensure food security for the projected 10 billion people. So this is more than a dietary shift. This is a systems shift. It is a chance to redesign how we feed ourselves in a way that supports people, non-human animals, planet, and future generations. Because at the heart of all of this, we need a food system that works with nature and not against it. And the good news is we already know what to do. We know the path, we know the stakes, and now it's just time to act. Thanks.